Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and it is indeed time to begin. Let's get to it, shall we? We're talking not rational exponential functions this morning. So let's see what is behind door number one. All right. First of all, an exponential function is a function in which the variable occurs as part of the index or exponent. So that's just simply 2 to the x, since the variable, like y equals 2 to the x, since the variable is the exponent, or in the exponent, then it's an exponential function. You could have g is equal 3 to the 2x, or 2x plus 1, something like that. That's an example of an exponential function. The simplest that we have, let's go ahead and get rid of that, is a to the x, where a is a positive constant and a is not equal to the 1 for obvious reasons, because 1 to the anything is equal to 1. That, or the graph of that, would be a horizontal line. So, 2 to the x, the most famous of our exponential functions, is graphed right here. And then g of x is equal 1/2 to the x, or to the negative x, is graphed alongside. And notice it's just a reflection in the y-axis. Okay, so just a couple of basic things that we must know. All graphs of the form of f of x equals a to the x, where a is positive and it's not equal to 1. A horizontal asymptote is going to be y equals 0, or the x-axis. It shall never cross or cut the x-axis, but it will approach it as it goes to negative infinity in this case. Okay, and it will always pass through 0, 1, since a to the 0, anything to the 0 except for 0, is equal to 1. So notice this point right here, as it cuts the y-axis right here at the point 0, 1. It will always do that. That's really, really important. Okay, and then, just convince yourself here. Why does it look like this? Well, when x is 2, for 2 to the x, 2 squared is 4. Yes, when x is 1, 2 to the first is 2. When it's 3 over here, 2 cubed is equal to 8. So you can see how this guy is going to shoot up very, very quickly, hence the term you hear all the time, well, it is growing exponentially. Say yes? Yes. Okay. And then also here, y equals 2 to the negative 1, right? When x is equal to negative 1. Well, 2 to the negative 1 is equal to 1/2. So if you go up right here, you can see it corresponds to 1/2 on the x-axis. And the smaller that our value of x gets, the closer, right? Like for negative 2, x equals to negative 2. The closer that the graph will approach the x-axis. That's going to be 1 over 2 squared, or 1/4. So it's just going to keep getting closer and closer and closer to the x-axis. Okay, those are some basics. So now we just have to find these things. Let's find f of 0 for f of x is equal to 3 minus 2 to the negative x. So f of 0 is simply going to be 3 minus 2. You don't have a negative 0, it's just 2 to the 0. So that's going to be 3 minus 1, which is 2. So for b, we would have, or they're asking for f of 3. So that would be 3 minus 2 to the negative 3, yes. So that would be 3 minus 1 over 2 cubed, which would be 3 minus 1/8. So that would be 2 7/8, which we could also write as 16 plus 23 over 8 if we wanted to. Okay? And then for C, they're asking us to find f of negative 2. So that would be equal to 3 minus 2 to the negative negative 2, which would be 3 minus 2 to the 2, or 2 squared. So that would be 3 minus 4, which is negative 1. All right, so this was just an intro, boys and girls. Hope you enjoyed it. We have much more to come. Let's get to it, shall we? I am out!